Assalamu alaikum Physics 1 students. Today we will be starting Module 7, Gravitation, Lesson 7.1, Planetary Motion and Gravitation. New vocabulary for today, we will study Kepler's first law, Kepler's second law, and Kepler's third law. Objectives, we will be defining the three laws of Kepler. Let's discuss early observations related to planetary motion. In ancient times, the sun, the moon, the planets, and the stars were assumed to revolve around the Earth. This model is called the Earth-centered model. People used to think that the Earth is the center of the universe and all other planets and stars, including the sun, revolve around the Earth, which we know that is not correct or not the true. Nicholas Copernicus observed the motion of the planets, and he noticed that the movement of planets doesn't agree with the Earth-centered model, so he proposed that the Earth and other planetary objects revolve around the sun. Later, Tycho Brahe, using instruments designed in his own lab, arrived to the most accurate measurement of his time. The measurements and the data provided by Tycho was analyzed by a very famous scientist who is called Kepler. Kepler discovered the three laws that we will study today that describe motion of any or every planet and satellite, whether natural or artificial in space. Now let us discuss Kepler's laws. Kepler's first law is very simple. It states that the paths of planets are ellipses while they revolve around the sun. An ellipse is an oval shape with two foci points. The sun will be at one focus while the planet revolves around the sun. This is a photo of the paths of planets in our solar system. You can see that the path of the Earth is nearly circular, but for sure not a perfect circle, it's an ellipse. Now let us discuss Kepler's second law. Kepler's second law states that an imaginary line from the sun to a planet sweeps out equal areas in equal time intervals. First of all, you need to notice that the planet travels faster when it's closer to the sun at this part of the ellipse. It travels faster than when it is far away from the sun, like on the other side of the ellipse. Let's say we have this imaginary line connecting the sun to the planet, and the planet goes from point 1 to point 2 in 1 month. So it's sweeping this area, white area, that I will call A1. And later, on another month, it moves from point 6 till point 7 on the ellipse, so it sweeps out this blue area. Since both areas are swept in the same time interval, which is 1 month, so we can directly say that A1 and A2 are equivalent. Here is another sketch. So the area swept in the same time interval is all the time equal. This area A1 is equivalent to this area A2. Now Kepler's third law. Kepler's third law relates the motion of two different planets. It states that the square of the ratio of the periods of two planets revolving around the sun is equal to the cube of the ratio of their average distances from the sun, as an equation TA divided by TB, where T is the period, the time for one revolution of the planet around the sun, squared equals RA divided by RB cubed, where R means the distance the distance between the centers of the planet and the sun. Here is a sketch in order to understand it better. Let us say this is Venus and this is Earth. R2 is the separation between Venus and Sun, and R1 is the separation between the Earth and the Sun. Kepler's third law formula states that T2 divided by T1 squared equals R2 divided by R1 cubed. Be careful for the exponents here. And you can write it the other way around also, it will be correct. T1 divided by T2 squared equals R1 divided by R2 squared. Here you can find more problems and examples and a quiz for you to do. You can find this PowerPoint in the resources folder. Please now go ahead and take a look at the problems you have. For today, you are requested to understand Kepler's 3 laws, take notes in your notebook, and then turn them in. Thank you very much, and if you have any question, please feel free